Good evening and thank you all for joining us today. My name is Rashmita and I'm the event planner for Microsoft Reactor Bengaluru, India. This session will run over the next 60 minutes including Q&A. The session is being recorded and will be uploaded to our Reactor YouTube channel. I will share the link to our YouTube channel in the chat section soon. Before we begin, please take a moment to read our code of conduct. We are all here to learn together, so please be respectful of other people's views, understanding of differences, being kind and considerate in the way you engage. The chat will be open throughout, and we do encourage you all to participate. Also, please keep your mics muted during the session. I would now like to welcome Shivam, our speaker for today's session. Shivam is an author, cloud architect, speaker, and co-founder at TechScalable. He is passionate about technology and works on Azure, GCP, machine learning, and blockchain. He is also a Microsoft certified trainer. But for now, I will hand over to Shivam to begin the session. Over to you, Shivam.
Thank you, Rashmita. I will quickly share my screen. Okay, so let's get started. Good evening, everyone. Hopefully, hopefully all of you are doing well. You are at home, you're safe. Okay, so let me walk you through the agenda for the day and then we'll get started. So if you have joined us for any previous session, you may recall that we go to the problem statement first. We understand what we are trying to solve. We spend some time into the details about the problem and then we solve it with the technology. So let's go through the problem statement and just before that, let's go through the learn module as well, which we can uh, which we can go through after the session. So if I take you the meetup page and if I just scroll down over there and if I open this link will take you to the learn module. So learn module is hosted or it's deployed or it's there on MS Learn, and basically it's a step-by-step structured document which we have created, which is there for you to follow. Just give me 1 second, guys. Okay, so check this out. So in this learn module, basically we have it's called as build and operate machine learning solutions with Azure Databricks. In the session today, we'll be going through this, and it's something which will take some time to cover. So you may have to spend. We can say after the session, you can go through it again, and you can go through it in a more step-by-step manner. So if I walk you through that, first of all, we get started with Azure Databricks. We see what are the various things inside Azure Databricks, what's a cluster, and so on and so forth. How do you work with data as such? Like it's pretty working with data frame is you can say pretty common in machine learning, right? We do that. But when we talk about Databricks, we are talking about the data frames which are in Spark, right? So then we have to think about the memory management as well, the space and how do you upload your data? How do you get your data over there? So a lot of things comes into picture. So how can we work with the data? How can we prepare the data for machine learning purpose? This is something which you will, if you work with machine learning, this is something which may be very familiar to you. How do you do that? But here you will be doing it in a Spark cluster, Databricks. So we train the machine learning model. We use MLflow to track the experiments in Azure Databricks, and we manage the machine learning models. We do that, and we can track the machine learning model with Azure Machine Learning Service, which is the custom AI solution of Azure. And then how do you deploy the models? So you can deploy into, for example, you can deploy into Kubernetes or you can deploy into container instances. So that part, I'll show you the container instances today itself and how can you tune the hyperparameters. and how to do distributed machine learning or deep learning with Databricks. So this is the learn module. And after the session, you can simply open that link and you can go to this page and you can follow it step by step in at your own pace. And you just have to log in on the top and your progress will also be saved. You don't have to put any bookmarks over there. So if I'll just click on any one of them, we'll go back to the to Azure. But if you see, like what is Databricks, we explain the here all the basic components are explained. We will also go through these components over there, but just to show you that everything is also documented and you can also go through. Apart from the recording, you can also go through this document and you can also perform these steps. The labs will be there. Okay, so this was about uh, the the learn module over there, and the link is in the chat window. Okay, so let me bring you or let me get you back to the problem statement for the day, and let's see what we are doing. So check this out. I'll walk you through all of this. I'll walk you through how I created this page, how these are the various modules which I showed you, right? I have them in my Databricks workspace. I'll bring you to this point and from there onwards we'll start. But before that, let's have a look at the data set. So we are working with so first of all the data set. I got the data set from Azure Open Data Set, and this data set is coming from here. This is the original location from where the data set was we can say was made available, and it is of New York Taxi. It's called as New York Taxi dataset. And basically, if I just walk you through this, if I click on few of the tabs over here, there are different type of taxi cab dataset like yellow taxi, green taxi, hire for vehicle for hire vehicles as such, the commuter vans. So we are using the yellow taxi dataset, and this dataset is the yellow taxis are licensed to pick up the passengers from the street anywhere in NYC like that. And green taxi is also having its own area from where it operates and so on and so forth. So this is a data set which we are working with. And let me see if there is something else which I can show you over here. Okay, some more details about that. So basically the rest of the details will be on this page. So if you work with open dataset of Azure, there are other datasets also. These are real datasets. You can do analysis on this real data set. Now, just to give you the importance of working on real data, when the New York Taxi data set was what was you can say released for the public, when it was done, the different you can say a lot of individuals they did various type of analysis on the data set. They found a lot of things which affected the way people or you can say affected the policies in New York, if I can say that. So, for example, they understood that there are a couple of lanes or there are a couple of streets where the parking ticket uh, fine is very high. So, and it's you can say it's pretty high versus the other streets as such. So those streets were identified, and when it was visited, when it was further investigated, that it was found that on those streets proper parking lanes were not created, or or there were some old markings were there, parking markings were there, and they were no longer visible. So when any individual parks his car over there, in most of the scenarios they get a parking ticket. So these type of things were found when analysis was done on the real data set. And once and then as you can imagine that those streets lanes and those problems were solved in the real life as well. So working with the real data set makes a difference. So you can find these open data sets here, and there are of other types as well. COVID data set is there, and population safety data set, and so on and so forth. Diabetic data set and other things are also there as part of open data set. We are working with the taxi data set right now. And if I just walk you through the attributes which we have over there, the columns which we have over there. So we'll walk through them these columns first, so we get a little more context of what we can talk about, and then I'll take you back to Databricks and I'll show you the various things you should know from Databricks point of view when you're doing machine learning, right? So if I just walk you through these columns over here, you can just look up for this page, right? You can just use any search browser to find this page. Okay. So basically, we have attributes like taxi zone in which the taximeter was disengaged over there. We also have attributes where like extra charges were charged, and what was the amount of the extra charge, time and distance calculated by the meter over there, the tax which was that is automatically triggered based on the metered rate in use, the taxi zone in which the taxi was engaged, numeric codes in you can say signifying how the passenger paid for the trip, credit card, cash, no charge, and so on and so forth. And then the the flag where the trip record was held in the vehicle's memory before sending to the vendor as such. Now, apart from this, total amount of the tolls which were paid over there. Now, apart from that, the distance in miles reported by the taxi meter. The code indicating TPEP is basically taxi and passenger enhancement something. It's like a it's a program in which they improve the taxi and the passenger you can say improvement programs are there. So these are those programs. Sorry, and one, sorry, I think that one is this one over here. This is technological. This is technological partner, like the person, the company who's providing the technology for the like the technical partner of the solution who is providing the technical partner. So very phone or creative mobile technologies like that, technical partner. And this is basically what I meant by that. The passenger and the driver enhancement programs are there, something like that. You can look up further for them. Now, this is the preview of the data which we have, and this is a data set which we are working with. So basically, we go back to Databricks, and let me take you to the Azure portal, and I'll get you started from here. And before I jump there, I just want to take you. I have few of the things in the whiteboard here, which I just want you to understand, and then we'll go back to the example. Now we are Databricks is a Spark cluster. Basically, it will we can create the Spark cluster there, Databricks Spark cluster, and when we do that, we have uh, there will be a driver node, and driver is basically where the Spark session will be there, like that. Now, apart from this driver node, whenever when you will submit the application, basically the app master will come up, right? So something like this. Let's say you have submitted the application, and then there is one app master, which is not in the screen right now, but like that. And then the Spark session is there, and the number of executors will be one in Databricks. So this diagram is of open source Apache Spark. In Databricks, what happens? They have one executor in one node. So that's one thing I want you to remember. So like one executor only, like not three or four, like I have made over here. This is open source a Spark, the generic Spark architecture. So executor is where basically the execution happens. This is where the task they run, and task are the one. So whenever you submit the job will be. So if I submit the job, let's say like that, the job will be broken into stages like this. There will be multiple stages, and then stages will be having multiple tasks over there. So the tasks which are there inside the stage, they execute parallelly over there inside the executors. So these two are getting executed maybe here and there. There can be more than one task also, like this. Like this, we have more slot options. So which is not in the screen right now, but there can be multiple tasks there. So this is how the Spark will be looking like, and the jobs will be broken into stages by the DAG scheduler, and then further the you can say further task will be there. So this happens inside the Spark cluster, and this also happens inside Databricks. The only exception will be that there is one executor in uh, one machine over there, like that, one node like that, one physical, not physical, one virtual machine over there. Now, apart from this, let me see if I just want to show you a couple of more things. So this is a typical, these are the various steps which might be there, or this is how you can differentiate, or these are different, you can say, concepts which we may have to understand, like the various type of data sources. How can we get it from various sources? What are delta tables? Delta tables are, we'll go through them. What is a feature store? When you do the machine learning, you can do two type of machine learning. Either you can do it yourself, like manually, or you can use AutoML also. So both the things can be done. We work with the notebooks. So notebooks are like Jupyter notebooks. We call them Databricks notebooks here. And experiment is like an umbrella where everything is logged. All the details are there. Everything is in one place. The trained models, they once you have the trained model, you also practically in practical life we also need a registry to save the trained model for versioning purpose. It's uh, like the storage location where the trained model will be stored. So then we can further use it beyond that point. We can deploy it, or maybe we can train another one, and so on and so forth. So model registry is also there, and then we also have the capability of deploying it and serving it. So I'll take you back to the Databricks, and I'll just walk you through this diagram which I have taken from their documentation, and I'll take you back to the Databricks as well. So what I have done is, this is my Azure portal, and I have it looks slightly filled up right now. I was working on something else. So, but if you just what I have done, I have simply deployed one Databricks. This one. This is my Databricks workspace over here. And apart from that, I'm using one data lake. Other things I'm not using right now. I'm using just one of the data lakes over there, which is over here, I think, Shivam's data lake, like that. So this is a Databricks. So when you make this Databricks, basically you get two options over here. I'll give you a little bit more, you can say, background about it. So if I click on Databricks like that, see, and if I just click on it, we get these two options over here. We have two type of workspaces you can go for, the standard and the premium workspace. We generally prefer the premium workspace. It provides the RBAC with Azure Active Directory, and it also provides the credential pass-through option. Credential pass-through option means that the credential pass-through option means that if I have read access on the data lake and I run the notebook, then the notebook will run with my access, like how much access I have. So if you run the notebook and you have write access on the data lake, write access, then the notebook will have that much of access. Like your job will have that much of access. You can write, but I cannot read. We both might be running the same job. I can read, you can write. That's credential pass through. So that option comes in the premium one. So we use the premium one. It's more practical. Generally, we go for this. The standard is also available, but these functions are not there. So I made the premium workspace, and this is how it looks like once it opens, like that, something like this. Now, now if I just give you a walkthrough of this, in Databricks, you will notice that if I click on this option, if you have worked on Databricks for many years, you may have realized that we only used to have the first one, right? But now we have the other two also. So now this is the interface where it's for generic data science and data engineering. That's for specific for machine learning, like machine learning things will be there. And the last one is for the SQL endpoint. This is for the SQL analyst as such. So the one which I'm using right now is this one. I'll click on that. So I'll just switch my workspace, and I'll just pin it so it doesn't go back. Now, if you notice this, we have the workspace option over here where the notebooks are there. These are the code notebooks where you will write your the code as such. And then apart from that, this is the data section. And in this data section, I have uploaded the data set, the New York taxi data set over there. Now I'll walk you through that, like how I got it there and what are the various ways in which you can get your data in the cloud. But this is the data set which I have over there right now. In the compute cluster, I made this cluster. It's having two nodes right now. And if I click on create cluster and walk you through the other details which we have, there are three type of cluster modes you can go for. Single node is for, you can say if you're doing, this is single node, like there is no concurrency there. It's the execution will happen inside the driver only. So if you're doing something on a very small data, or maybe you're doing something for dev and test purpose, then single node is okay. Standard and high concurrency both are production oriented. Standard is the one when you're working on a type of data which is very big. You're doing something a very heavy job as such. You're running something which is working on a lot of data. We also call this as single user cluster. Like five data scientists will have five standard clusters, their own clusters, like that. So it's sometimes it's difficult to get the cost down. In high concurrency clusters, we are able to these are shared clusters. Multiple people will share these clusters. So they submit the job onto the same cluster. So uh, it also basically resource sharing is happening over there, right? So you understand that the cost we will be able to get the cost down. So typically, a lot of times we make the high concurrency cluster as such, but both are practical, right? Okay, now some other normal things which we have on this page, like what type of runtime do you want? Go for the long-term support runtimes, because you don't have to, like, long-term support is better than like the constant maintenance. Instead of constant maintaining your code, it's better you go for the long-term support runtimes, where the functions which you are using, the frameworks, or the feature which you are using of Spark is supported for a longer period of time. You don't have to worry about it getting changed. So go for the latest long-term support. And the one which I'm using is the machine learning long-term support 10.4 over there. This one over here without GPU. In my free account, GPU is right now, in this demo account, GPU cluster is not supported right now. In your production account, you can go for it. So the one which I have is this one right now, the 10.4 long-term support machine learning. It is having specific version of Scala and Spark. So auto scaling is enabled, and it is scaling as such. Termination after 120 minutes of an activity, which is very self-evident, that is there. Spot instances basically means that if they have extra compute on discount, sorry, if they have extra compute in that region, then I will get some machines on discount. But when the compute will be utilized by Microsoft, or when they will take it back, then these spot instances will be replaced by the dedicated instances. So I'm not using that option, but if you don't have any, like for example, there are two type of thing. Like if I just show this to you, we have compute optimized, compute optimized solutions, memory optimized, uh, like this. Various type of optimized solutions are there. So if you're thinking of something like cost optimized, then you can go for the spot instance, but there is a chance that the spot instance will get deallocated, and the on-demand instance will take some time to come up. So your job will be affected in that point in time. Okay, so these are the normal features in the cluster. That's the credential pass through. Now, from machine learning's point of view, we have experiment over here, like this. So experiment is where all your experiments will be centrally logged in one place. So I have just executed these experiments like 1 hour back. So you will notice that I can click on any one of them and we'll see some more details over there. So the experiments ID is there in case I have to use that experiment ID. And then it was started some time back, and who ran it, that's the username which I'm using right now. The model was a Spark model and regression model. So the matrices are also there, like the various type of metrics which are also there for regression. So this is where all the things will be in one place. We can also create the AutoML experiment, and I don't have it right now, but we can totally make it. Like, what type of problem statement are you looking for? Classification, regression, forecasting, and you can browse your data set, specify the target attribute, the name of the experiment, and just start the experiment. So it will take some time to, you can say, execute. But to control the time it will take to execute, you can put the exit conditions or the stopping conditions over there. So it will execute, it will terminate after 60 minutes. It depends on how much budget we have and how much time we have. So based on that, you can specify some conditions over here, and some give the data directories and all that. So, and what type of metric are you looking for? So because we have selected classification, it is showing classification matrices over here, like accuracy and precision, like that. So this is the AutoML part. So this is where we were talking about that we can do the model training either manually or with AutoML. In both the ways we can do it. Now, if I walk you through the rest of it, this is where we have the feature store. I don't have anything right now, but when we do let's say you generate new features, new columns are there. You aggregated new values. You have derived some new columns and so on and so forth. You want to use it. You want to share it with other team members and so on and so forth later on. You can also do that. So the if I click on the model option over there, this is where we save the trained model. So this is one model which I have, which I created, which is you can say ready for the serving. This is dummy right now. It's not having any specific model. I still have to register it inside it, but this is just to show you that we can have the model registry where latest versions will be there. Is the model for staging purpose? Is it for production purpose? Can I serve it or not? Serving is like deploying it or not through an endpoint. So I'll take you back to my workspace now, where we have the code notebooks, and let's understand how we are dealing. What are we doing for this customer? And on this data set, what are the various things which we are doing? And I will just zoom out over here just to show you a couple of more things which I have in the data set, which I have in the whiteboard right now. We will be using MLflow. MLflow is one library by which we can do the tracking of the it can do the logging tracking when the model will train as such. So we have the tracking server, we have the model registry MLflow, and everything will be tracked. All the parameters, the artifact, model, metadata, all the different type of matrices will be there, and the all the model registry will be there, staging, production, and so on and so forth. Everything will be there. Now the simple things can also be done. Like if you, in case you have to like who is having how much rights can also be done. So administrative policies and access control can be given on the cluster job, the model registry, and the workspace level. Like different colleagues of ours will be having different rights on the cluster, right? So those type of things are also possible. Now, something I just want to show you this, and then we'll just jump into the code part. So there is a particular concept called as Delta Lake. You may have seen that. You may be aware of it. I'll show you the. It just show you like this. So this is Delta Lake is basically open source. You can just look up for this delta.io in any of your search browser and you can read more about it. But what Delta Lake does, Delta Lake basically provides the asset compliance or transactional support layer on top of the data lake. So we have data lakes in all the clouds. And in Azure, we call it as Azure ADLS, Azure Data Lake Storage Generation 2. That's the name of the service which we have in Azure, which saves the or which stores the data. It's this is a replacement of HDFS in big data ecosystem. That one, the bottom one. So this is having no limit and it saves the data over there. Now, so data lakes are great, but they don't have asset compliance. So there is no asset compliance over here like that. If something things don't roll back like it happens in databases, right? Things go corrupt. So this is the transactional support layer, which provides the asset compliance, and it is already open source and it is already available in all the solutions in Azure and also in the one which we are using in Databricks. So what happens is the we are able to store the information. We are able to work with these delta tables. So what we do, we create tables over here like that. Table is maybe may not be the best word to maybe for if you're look if you don't know it basically. But what happens is when we make something over here, the data is stored inside data lakes like that. So the delta format at the backend is a Parquet file format, and the data is persistent inside the data lake. But from the delta lake's point of view, we are able to make the tables over there. So if I just walk you through that, like when you make the tables in Delta Lake, we have three. We these are not keywords. These are just like theoretical. You can say differentiated. You can say we are differentiating between these between different type of tables over there. Like that, if you keep your raw data, then we will call those type of tables as bronze tables. All your raw data will be there. And in the type of tables where you have your silver data, those or sorry, your enriched data, transform data, clean data, those type of tables we'll call as silver table. And then the data where you're on top of which you can do aggregation or aggregated data or BI ready data or reporting data is the gold tables. So when we get the raw data, right, and you clean your data set, you transform few features, you clean the data set, you take care of the missing values, you impute the values, maybe you drop some values, you take care of the cyclic features over there. So then you save it. You also may need it maybe in the next iteration when you start working on it again, and also somebody else also may need it as part of your team. So when we save it as delta tables, and at the backend it goes in your data lakes. So these data lakes, you have to mount it first. It's not by default, it will not be mounted. If I don't mount it, then it will go in DBFS. So I will show you. I'll go take you back to the code. But there is a particular file system in the cluster, or you can say there is the file system which is local to the DB to Databricks, is called as DBFS, which is available to the cluster as such. So if you don't mount your data lake, or if your data doesn't go in the data lake, it will simply go in DBFS like that. DBFS is not. It's first of all. It will be having some limits also, and we prefer keeping the data in the cheaper data lake as such versus DBFS, which is a local file system. So if you don't mount it, then the tables will basically get created here. Like this is where they will persist in DBFS. And just FYI for your knowledge, DBFS at the backend is persistent in a storage account like that in Azure. So let's go to the code and let's see what is going on over there. So if I okay, so we basically this is how the Databricks notebooks they look like. Right, these are simple notebooks. If you have worked with Jupyter notebooks, you already are familiar with these, right? Like this, you can add cells over there and so on and so forth. Now we have there are four programming languages which are supported in these notebooks. I have to go one page back to show you that. Over here, if I create another new notebook, then I can show you that we have PySpark, Scala, Spark SQL, and Spark R like that. Like this. We can also run jar files as well, but jar files needs to be executed in the jobs over there. So like that, you can run multiple programming language in the same notebook. You just have to put percentage Python, percentage Scala, percentage. You can say you have to specify that, and you can run multiple programming language in the same notebook. So my cluster is attached from here. It is having 28 GB RAM, 8 cores are there right now. And if I just take you through the notebook. So all these steps are there in the learn module, right? All these steps are there. I'll walk you through these. Now the okay, this is what I meant. Okay, it's actually written there. I could have shown this. So for example, if I want to run Scala in Python notebook, right now this is Python notebook. See over here. Either I can change it from there. I can change it to other types over there. But if I want to run some Scala piece of code, or let's say SQL, which I am also actually using in this, if I want to run that, I can just put it like that over here. Now, if you see, it became a SQL type of cell over there. So we can execute SQL queries now inside this. So, uh, right, so we can do so we can define our own functions also here. And this is what I was telling you about the data DBFS, Databricks file system. So DBFS is layer on top of the object storage, which in Azure is storage account. And uh, the lifetime of files in DBFS is not tied to the lifetime of the cluster, meaning whatever file you have, even if the cluster goes down, comes back next time, then your files will still be there. But what I want you to understand or do is something like this. Like we write our data in the data lakes over there. So for the purpose of writing the data in the data lakes, we have to there are two ways in which you can connect to the data lake. Either you don't mount it, you directly write into it. The only tricky part over there will be you have to remember all the path and what particular folder you are writing into, and so on and so forth. When we mount it, it becomes slightly easier to work because it's like a locally mounted file system. So your data lake like that will be mounted like a local mount point. Whatever mount point you will say over there, it will mounted be like that. So if I do something in this path, it happens in the data lake over there. Now here on top of it, we have the concept which I told you before, the credential pass through concept, meaning that if I have read access in that mounted path, when I run the job, my job can only do read. But if you have write access on that mounted path, uh, on that data lake, the real data lake, which is in the resource group right now, so then your job will be able to write. So we can do credential pass through. So my user credentials or my as an employee, whatever rights I have will still be enforced, which is very useful for us. I'll recommend you think about that. Now, so if okay, now we can also mount it using the keys as well, like this. So this is the code snippet where the keys are given for the mount purpose, and it can be mounted here. You can also visualize it. It's not that you only have to list it out. You basically can do this. You can click on the setting over there, and you first have to enable it. Like I have to first go to the workspace setting, and I have to find the option which is called as the DBFS file browser. Enabled by default, this is disabled. Once you do this, you will be able to go to the data section, and then if you click on DBFS, you can manually also see it. See, this section will only be visible once you enable it from the previous setting over there. Now, whatever I have mounted is already, or you can say all these path which you see over here, you can manually go in, you can browse it like that, like okay, in this manner, like that. So things will open. You can further go and find your files over there. Now, okay, so this is like just getting started with the Databricks. There is not any machine learning here. It's just like how to what to do, how to click on it, and so on and so forth. Then what we do, we basically start working with the data after that. So the second learn module which we have in MS Learn, this is the one working with the data in the Databricks. So there are a couple of things which I want you to look at. See, check this out. So because you're working with those delta tables over there, you are able to run these. You can run SQL queries on top of it. You can, if you're familiar with this, it's sometimes it's easier to be able to do a few things with SQL, and it's easy to explain to other people also. Like if you want to explain this to somebody who's to your manager, and if they are not hardcore developers, then maybe it will be easier for you to also walk them through this query over there. This is anyway just select statement just to show you like things are still loading over there. Now we can also, yeah, so you can also load your data and data frames using the Spark SQL over there. Now we can read the data from, so if you see, we have this spark.read, spark.write. You have to specify the file format and then the path where it is. So right now it is in DBFS, but once we mount the data lake, we just have to give the mount path like /mnt/ something, and then the rest of the path of the data inside the data lake. And is the header true? Do you want to infer the schema? Do you want it to infer the schema? All of those type of things needs to be done. And this display command is basically displaying it out. Okay. Now we can definitely count the number of rows which are there. I'll just zoom out and I'll find something which I want you to uh, go through uh, go through that right now. And there is one thing which I have kept open in my. I have kept one tab open over there for us to go through. Let me quickly see. Okay, feature engineering. Now, okay, so if you go to the learn module, we are doing these four things over there. We will handle the missing data. We'll do feature engineering. We will scale. We'll do some scaling, and we will encode the categorical features over there. Now, the missing data. So there are many things which comes to mind when we think about missing data. You can, if you have a lot of data and you have very less rows which is having missing data, you can even drop those rows. But when you have limited data and you cannot drop your rows as such because you anyways have limited data with you. So now we can drop these records. We can also we can add one placeholder like -1, and then we can see the missing data later on without you can say violating the schema over there. We can also do the imputing. Imputing is what we mean by like you impute, you put another data point over there in place of missing data. Now you can think about mean, mode, median, but be careful about what to use when. Now advanced techniques can be there like Smart as well. And what Smart does, Smart also generates you can say generates synthetic data. So I'll just tell you about that Smart. So it looks like this. So when we have imbalance in the data set, we have various ways in which we can deal with it. You can do oversampling, you can do undersampling, oversampling of the minority class, undersampling of the majority class. Or what you can do is one thing is called a smart synthetic minority oversampling technique. So it looks like this. It's very straightforward. The pseudo algorithm is very straightforward. So if this is my data point, imagine this is my table over here, and I have some values. Let's say this is x1, uh, x2, and the class is right now, let's say 4. And this triangle is the minority class. That's what we are thinking of, right? And we want to generate some synthetic data points of the minority class. So I have this, let's say 3, 5, and another minority class. So if I plot those points, they will be looking something like that. Let's say this is the 3, 4, and the 2, 5 will be, let me make it, let's say 2, 2. Looks better in my diagram like that, somewhere here. So what smode does in the pseudo algorithm of smode, basically this distance is found, Euclidean distance or the cosine distance as such. So once this distance is found, we multiply the distance with one random number between 0 and 1. So one new data point is found. See, like that. Imagine this one. So whatever this new data point is there, like that. So let's say it was between 2 and 3, and it was here 2 and 4 over there. So this looks somewhere around 3, and let's put 2.5. So hypothetically 2.5 and 3 is my new synthetic data point. So this data point was created by Smode. This is what Smode does. It oversamples the minority class by generating synthetic data points. We definitely would like to get more data point. Like it's better to always get real data, but when you work with anomaly detection, you may not be having that data in that point in time. So you can use these type of techniques over there to do that. Now, the one which I want to show you is this one. This is very interesting. When we are doing the feature engineering now, and if you really think it through, there are few features which are cyclic in nature. Like time is, for example, the hour of the day is cyclic in nature. Like the cycle repeats, right? The hour repeats after 24 hours. It will again repeat as such. The seasons will also repeat. The various seasons which we have. So there are some features which are cyclic in nature, like that, like time, or we have the cyclic seasons as such. But when we work with those seasons, oh sorry, when we work with these attributes in machine learning, the algorithm doesn't understand that it is cyclic. They understand that okay, there is a difference between two data points. So if you think it through, let's say 23, 11, 11:15 in the night, right? There is a difference between 11:15 and maybe 12:15 early morning, like that, 0:15, like that, right? 15 minutes past, or you can say 15 minutes past 12 in the morning. So there is a difference between that, but it doesn't understand that it's a cyclic feature. Like it went in a cycle, it went to the next day as such. So if which is which you understand, because you guys are able to understand that, but these machine learning algorithms don't understand that. So we have to take care of these cyclic features. So what we do, we basically use the sine and cosine functions to make the or to we break that particular column into two columns, and those columns are created with sine and cosine functions. So I kept one page opened over here. I found it on internet only, and I found it to be very straightforward for my example right now. So I kept that page open over there. And so this is some cyclic features which he has generated over there, the author of the blog. And these are right now looking something like that. It's not, they're not getting, you can say, properly captured in the data. But then we break the data into sine and cosine into two new columns. That column is now, you can say, decomposed into these two columns over here, where we have the sine and the cosine function. And the sine function basically captures one part of it. The cosine functions captures the other part of it. And when we plot both of them together, like the cosine versus sine, it becomes like it also in graphically also it looks like a graph as such. So this is the one where we understand that the cyclic nature of this particular time column, it has been, the hour of the day has been captured over there. We're talking about the hour of the day, like that. So 24 hours are there, and this is what we are also doing over here, but the diagram was not there. So when you will do this learn module, you will also perform that cyclic, you will take care of the categorical feature which are cyclic in nature by using sine and cosine. So now which are here, the r underscore sine, r underscore cosine, both are required to capture it as such. Now apart from this, we do other things also. We do there are different type of data types as such. Categories are there, numbers are there, time series data, text data. So we take care of it. We also do the scaling of the data. Sometimes what happens, the data will be squished on one of the will be squished on one of the axis, and or will be more the spread will be more on one axis, or it will be more it will be one of the axis will be dominating the data. We do the rescaling to take away that dominance over there. So normalization will do the rescaling, standardization will do the rescaling as well. Now, like this, and we cannot work with machine learning works with numbers, right? So you have to encode the categories into some numeric formats over there. So one of the older methods, or one of the methods, is called as one hot encoding. Uh, this may not be the primary choice if you're working with text analytics, but one hot encoding works out uh, in non NLP type of scenarios way better. So that's what we do over here. Now, so we have taken care of the features over there, and then we are training the machine learning model over here. Now, what I want you to go through is that we are using a thing called as a pipeline. Now, what happens is when we like, this pipeline is not your DevOps pipeline or something. This is like a machine learning training pipeline right now, which means that there can be various stages. So let's say you got your data, you have cleaned your data, you have then you did some feature engineering on top of it. Then you took care of the categorical data, and so on and so forth, and then you finally trained it. So different stages can be defined. You can say stage 1, stage 2, stage 3, stage 4, stage 5, register the model, stage 6, maybe deploy if you want to do it. So then those stages can be made into one pipeline and then executed. So it makes it modular. It makes it we can use heterogeneous locations to do it, to run those individual stages as well. It's better to, you can say, when we have to encapsulate this inside one MLOps pipeline, it becomes better to work with the pipeline concept. So that's what we will be doing in this section. Now, I want to show you the major part over here. So notice this. So MLflow is the you can say one of the default ways by which we will do the model tracking. So once we initiate the MLflow, the model tracking starts happening. So I can so basically, if I go to the through the experiment section over there, over here, so all this model tracking has happened because I have enabled the MLflow over, and all the when you run something, the all the various type of parameters which needs to be saved, all the metric values over there, everything as such will be tracked for you, and you can go in later on, you can understand it. The descriptions will be there, parameters will be there. Okay, so how many parameters were there, uh, what type of different metrics were there, and if there were any tags or not. Like tags can be, let's say, is it production, is this model for is this experiment for stage purpose, or what's it's for production purpose, or any other tag which you want to use, like which library was used over here to do the model, to do the hyperparameter tuning. So this was the library name which was used for this. After 10 days, I won't remember it, right? Like which library I may have used it, or if I give it to somebody else, and I have, let's say, 100 notebooks in the workspace, then it will be very difficult for them to track it. So if we properly document it, then it will be easy to for someone else to also take it forward and get in hold of it. So all those details can be put in the in the tag section over there. Now, so these are the capabilities of the ML flow, and what I want to show you is one more capability, which is over here. Now you will notice that what we are doing here is we are connecting this with Azure Machine Learning Workspace. So this is Azure Machine Learning Workspace over here, like that. So this is the default, you can say de facto, or this is the solution, or this is the service, Azure Machine Learning Service, which is where we create custom AI solution. Like in Azure, there are three type of solutions: custom AI, pre-built AI, and conversational AI. So custom AI solutions are created in Azure Machine Learning Service. Now, Azure Machine Learning Service provides integrations with other solution. Like I can, if I'm designing something here, I can submit the job onto my Databricks cluster over there. So like, sorry, attached compute over here, like this. So integrations are provided. Like I can write the code here, run it in Databricks, run it in HD Insight, which will provide me with Hadoop and Spark. I can run this in Kubernetes. I can also, so the model training will happen in Kubernetes over there. This is a new one, not the deployment of it. That's also there anyways, right? Thus, we can also use the Synapse Spark and virtual machine. So generally, what happens is that the companies who are working on Azure for many years will be using this service over here for their model management, and they also would like to use the Spark capabilities. So if we can connect both the best of both the worlds, like the parallel distributed nature of Spark and how it runs as such, and also the custom AI solution, then it's like best of the both of the worlds as such. So in because of that, we have the capability of connecting both of them. So it is not right now. This is like not the proper integration. I have previously done many sessions where we literally properly connected both of them, and we connected Azure Machine Learning Workspace with Kubernetes Azure Machine Workspace with Synapse Azure Machine Workspace with uh, with Databricks as such. Uh, so this is right now over here. We are just sort of doing a partial integration in a sense. And these are some of the details, like in which resource group machine learning workspace is there. What's the name of the workspace, right over there. And then when we do the model training, the model uh, logging happens here. So you will notice that in machine learning workspace also we have the experiment section. So here the model logging will happen, and this gives me more capability. In my personal opinion, the machine learning workspace is more mature in terms of MLOps task than what we have right now in Databricks. I'm not saying that we cannot do everything over there, but this is more, you can say, more mature. And even to connect it, I had to install I went to the cluster and over there like this, and basically in the library I installed the ML SDK only to be able to do this, and finally was able to make it work, and did the model training, and the registration and the logging happens over there. Uh, and one more thing, if I take you back, apart from this, what I have also done, and when you will do the learn module, you will also be able to deploy it. So if I click on this last section, and that's where I will take your questions and we'll end the session after that, is over here that if I just take the main part. Okay, so so check this out. So the trained model is right now deployed in Azure Container Instances, and Azure Container Instances is having 3 CPU core, 15 GB RAM. It is running in East US, and it is already having an API endpoint which is exposed, so anyone can do the API call to it. You just need to have the key of the for the API, and then for the API endpoint, and you can do the API call to it. So if I just show you that container instance, let me see where it went over there. Okay, I'll take you back over here. So this is the ASI endpoint which is deployed, the workspace, and then to this is where we are doing the API calls. So it basically gets deployed, and we can also consume it. So that's the API endpoint, and then that's the key which is visible right now in the output section. But I'll anyways delete this service after the demo. So with this key and with that endpoint, the we can call uh, the New York taxi data set with the New York taxi model, which is there. Now, what this model is doing right now is a simple regression. Like we are finding the what that the deployed model is. So you will specify, you will the in the attributes you will specify that what is the distance, and then the predicted fare will be there. It will forecast the cost, or it will forecast the price or the fare of your taxi ride. So it's a simple regression model which is deployed there. Now I will take you back to the learn module as such. Now there are more sections. We are already have reached uh, the specified time as such. I'll take your questions now. But if you go to the learn module over there, you will find that there are way more details than what we can, what we what I configured, but what I covered over here. You can go to the hyperparameter tuning as well. You can see what are the various you can say the various uh, ways in which we can do that. Like there is one particular library called as hyperopt. With that we can do the hyperparameter tuning. So and understand the hyperparameter tuning. What is the meaning of it? How do we do it? What is grid search? What is the random search? How do you do that? And then how to do distributed deep learning with Databricks as well. So here, one convolutional neural network will be trained using in PyTorch and will be running in distributed manner in the Databricks. So it's over there. So the Learn module is available on the meetup page, and that is something which we can go through after the session today. I'll take your questions now. I'll just go through the questions in the chat window. Let me see if there are questions over there. You can also unmute and ask your questions. Okay, so let me go back to it. Yeah, recordings will be available. It will be on YouTube. You can join us on the Reactor channel. See, it's just pasted by Rishmita, the last link, Reactor channel. Okay, very nice question. How can I start learning with it? Does it need Python and Spark knowledge? Okay, so answer will be yeah, yeah. It will need you. It will need you to have some Python knowledge. But I'll tell you how you will. I'll give you the learn path for it. I can help you with the. So if you're ready to learn, I can help you with the next part, right? Like how to do it. So I'll open the. I'll show you a couple of links and I'll show you how can you how will you find these things as well. So what Microsoft did, they created this MS Learn. That's the platform, like MS Learn. Now this platform is very. It's not there in. You can say it's pretty interesting. They This is something which they have really done well, like really done well. So if you come here and you look for Python like this, so then you will get the, and then you go to the left hand side and you look for the learning path and say you are beginner or you are intermediate and so on and so forth. See, so now 3 hours of learning path. Some more, solve some basic mysteries. That is something new over there. Solve mysteries with Python. Okay, go and have a look at that. Space exploration with Python. This is one of our session. We'll be going through that. So very interesting. In very see, classify the space rocks with Python. So you will learn the data science world as well with Python in a very interesting manner. So you will stay motivated over there. Now, if I look for Spark, like similarly like that, if I look for Spark and I look for the learning path over there like this, then it's 2 hours of learning path. If I remove the learning path, I think I'll get more options. So here we have learning path means like in a more step-by-step manner, and then individual like scenario-based solutions are also there, which you can see are there in this page right now. So when you open this learn module like that, you can simply go to the browse section and you can browse for the various modules which they have over there, right? So uh, that's how we can go through all of this. Okay, so please ask your questions and you can unmute and ask your questions as well.
If you don't have any questions at the moment, you can always reach out to Shivam later.
Right, you can find me on LinkedIn. I'll be happy to answer your questions. You can put them across to me over there. And join us on the Reactor page. Join us on the LinkedIn group. Please find the links in the chat window. At 6:45, it was pasted by Rashmita. Just have a look at the links. And all three links are important, like Meetup page, the YouTube page where we have the recordings, and the first page, the LinkedIn page, where all the session links are also posted there, so you can go through all three of them.
Yep, and also you can find Shivam's social handles on the meetup page. So just in case if you want to reach to him at a later point of time, you're always welcome. And like Shivam already said, like, the Learn module, the YouTube and the meetup link, it's already there on the chat section. Do share your feedback about today's session and use the event ID, which is 15611, and give us the feedback how you like the session. And also please use the Learn module link shared in the chat section. This will give you access to additional resources to take your learning further. And for more upcoming session, please visit our Microsoft Reactor Bengaluru meetup page. Thank you, Shivam, once again, and thank you all for joining us. Enjoy the rest of your day.
Thank you, Rashmita. Thanks, everyone. Have a nice day.